Good evening everyone, welcome back to another daily Leetcode challenge. Today we are going to do the daily Leetcode challenge of 13 January 2023, that is question number 2246, that says longest path with different adjacent characters. So I have noticed from previous 3 days the daily Leetcode challenge is pretty much similar and they are giving you a tree question and you just have to apply the traversal and you can do it. So I request you all to please try it before moving on to the solution. And you can also check out the previous videos for a better understanding if you want. Okay, now, so see what the question is saying. The question is saying that you are given a tree which is connected, undirected graph and has no cycles. It is not a binary tree, okay? And they are rooted at node 0. Okay, the starting node is 0 node and they are numbered from 0 to n minus 1. Okay, that is alright. And they have told you that the parent of 0 is minus 1 and the parent of 2 is 0 and the parent of 1 is 0. So that is what you have told you about the parent. And they are given you a string. Okay, they are given you just a string which has some values assigned to each node or each vertices. It is pretty much similar to the same level question. In that question, we have to check whether the subtree have the same node or not. But now what we have to return? We have to return the longest path in the tree such that no pair of adjacent node have same label. That means 0 and 2 should not have the same label. That is all you have to do. Apply DFS and think around it. Then you can do it. Okay. So now let's move on to the example. Let me explain you the example, then we can do it. So what you have to do, we are given A. A will ask it, see every node will have a traversal value 1. Okay. If you are standing at 0, you already moved one step. Okay. So this one will be at every node. One will say, hey 2, does your children have A? It will ask its children. E will say, no, I don't have any children. I am a leaf node. So it will say, but I have E and I can return a path value 1. So it is returned. We will then check whether A is equal to E. No. So 2 will say, I also have one thing. So I will return 1. So the value at 2 will become 2. The longest path length currently. Then 2 will check with A. And they both are having same character. So 2 won't return anything to 0. Okay. So the answer is still 1 for the 0 node. And the maximum length is currently 2. Now the 0 will ask 1. Hey 1, does your children have A? It says, let me check. It will ask with C. C will say, no, I don't have any children. I am the leaf node. I have C and I will return 1 value. So it return 1. Then we will check whether B is equal to C. No, they are not equal. So 1 plus 1 become 2. Then we will ask this 4. It says whether your children have A. It says I don't have children, but I have B. And they both are B, so they won't be it won't be returning a 1 value. Yes or no? And now the B will say that I have total value of 2 and we don't have A. So it will be returned to this 0 node. So total value become 3. So now the current longest path length will become 3. So 3 should be the answer. So see, that is how you have to approach. Now let's move on to the second example. The second example has 3 leaf nodes. See, it is not a binary tree as I told you. So A will ask 3. Hey 3, do you have A? Does your children have A? It says I don't have any children. I am the leaf node. It will say I have C and I will pass you a value 1. It says okay. A is already having a value 1. So total become 2. Now A will ask B. Number 0 will ask number 2. Whether your children have A? It says I am also a leaf node. So I can return you a value 1. And we will check whether this A is equal to B. No, they are not equal. So 2 plus 1 becomes 3. Okay. So now then this 0 will ask 1 whether your children have A. It says no, I don't have any children. But I have value A and you also have value A. So we should not interact. So it won't return a 1 value. So the total longest path length will become 3. As simple as that. Are you getting it? You just have to apply DFS and compare the labels. Think around it. Okay. So now, so let's see the question again and move on to the coding part. So I hope you have understood the question and we can move to the coding part. Let me just zoom it for you and let's start coding. So what's the first step you will do? Yes, the first step you will do, you will create a adjacency list. But before that you have to create a n, integer n, which is parent dot size. That is the total length of the array. Yes or no? It will give the total length. Now you will create a vector of vector int adjacency list of size n. So what is the adjacency list? I have explained it in the previous videos. Please check them out. I will mention them in the description box. But now here I should also explain you what is an adjacency list. Okay. So see, in this question, adjacency list is simply you can say as the node adjacents are its adjacency list. The 0 node will have a track that it have neighbors 2 and 1, that they are its adjacent. Then 2 will say yes, my adjacent are 0 and 5. Then 5 will say my adjacent is only 2. Similarly, 1 will say my adjacent are 0, 3 and 4. And similarly, 3 will say that I only have one adjacent, and 4 will say I only have one adjacent. So this is how an adjacency list looks in a vector of vector. Yes or no? We are storing the adjacent relation among them. Why we are storing? So we do not have to iterate over the same node again, and we can store data. So it reduces our time complexity and space complexity. That's why it is very much important. So here, how can you create an adjacency list? You will write for int I is equal to 1, I less than and I plus plus. What we have to do? We have to do adjacency list parent I will push back the current I. Similarly, adjacency list I will push back parent I. Okay. So this is all you have to do. So what is this happening? It is creating a relation among these nodes. 0 relation with 1 and 1 relation with 0. As explained here. 0 relation with 2 and 1. 2 relation with 0. 1 relation with 0. That is what is being created here by the adjacency list. And here it should be a square bracket, because you are giving the index of the parent. You're taking the value of parent from the index. Okay. So that is how you have created an adjacency list. So now what's the next step? You have to apply a DFS call. But before that, let us create a return type. We have to return what? We have to return an integer. So let us create an integer. Let's name it as answer. What will be the value of the answer in the worst case? As I told you, minimum you have a value of 1 to traverse or move. So in worst case, it can return 1. Okay. And now you have to apply a DFS. So let's return the answer as our final answer. And in DFS, we will pass this answer and check whether its value is changing or not. Yes or no. So in DFS, what I told you, it is very similar to the previous question. It is simply that you have to pass the current node. The parent node, the parent of 0 is -1. They have also told you in the question. And you have to pass the string. Okay. And then you have to pass the adjacency list as well and also the answer. You can also declare them globally, but I prefer this way because I have studied in this way. Okay. Okay, so now what will be the data type of the DFS? The data type of the DFS will also be a integer because we are returning the total length of this 5 node from 0. So it will be a DFS call. Okay, and what we have to pass? We have to pass the current node, which I name it as node. We have to pass the parent. Parent for 0 is -1. We have to pass this string. And we have to pass it by reference. Passing by reference is so much important to reduce time complexity and space complexity. Because if you don't pass it by reference, several copies of it will be created every time DFS is called. So that will be a hectic problem for us to deal with. So we pass it by reference to reduce our space and time complexity. We also have to pass the adjacency list, and it will also be passed by reference. Here a small mistake. Yeah. Now it is correct. Adjacency list should be like this. And also we have to pass the integer answer. It should also be passed by reference. So our answer gets updated every time DFS is called. So what's the first step? We will create a int maximum length, which is 1. And how I told you to apply DFS, you will do the iteration auto traversal. Yes or no? You will traverse every node and check whether the current node is equal to its parent or not. So for auto v2 adjacency list node, we will do if v is not equal to its parent, we will apply a DFS call and by applying the DFS call, we will store the temporary value returned from this node to this in a temp variable. So now when we apply the DFS, the current node will become v, the parent node will become the node, the string will remain same, adjacency list will remain same, and the answer will remain as according to the DFS. When this is done, what's the most important step I told you about? We have to check whether this A is equal to its parent or not. Then only we can add it now. So we will check whether this A is equal to this A or not. How can we do that? We will write if S current node is equal to the it should not be equal to the parent node. Yes or no? The parent should not be equal to the current node character. Then only we can do it. Then only we can add it. And while adding, what we have to do, we will write our answer will be updated to maximum of answer or max length plus temporary value. Why addition of temp? I will tell you. And the maximum length will be updated to maximum of maximum length, comma 1 plus temp. So see, the answer should be updated every time because initially it is 1 and its value should increase. And how it is increasing, that I can show you. So see what is happening here. Every node value has one value. It is already having one. The minimum time is 1. Yes or no? So when we came here, it is already having 1 and the temp value is returning how much? It is returning 2. Then it becomes 3 now. The branches value are returning the temporary value and it itself has a 1 value. That's why the total becomes 3. So that is what is happening here. So that's what you have written. And when you are done with this step, you will return the maximum length to the DFS function so it can continue. And the answer it is getting updated every time and finally the answer will be returned. So let's check whether it is working or not. Yes, it is working. Let's just submit it and check whether it is correct or not. So yes, it is accepted. So this was a very similar question to the previous one. We just have to apply DFS and check whether the labels are same or not. And we have to return the maximum length. So I hope you liked the video, you understood the concept and you tried it on your own. Please practice it and do let me know if you have any doubts. Please like, share and subscribe the video. Thank you for watching. Bye bye.